The last thing we're going to look at in this section is solving systems of equations. In Math 1, you looked at solving systems of linear equations using graphing, substitution, or elimination. And the way you can use graphing is to look at where the lines or the functions intersect. And we are going to look at where these functions intersect to solve these that are not just going to be straight line linear functions. So we're going to use Desmos. If you want to find a solution to a system of equations using Desmos, we will type both equations into Desmos and click on the intersections. This is a system of equations because it is two equations. So we'll type both of these into Desmos. Okay, I have both of these typed in here, and I made you a note that if you need to type a square root, you could just type SQRT parentheses. That's how I typed in x plus 4. So I did x squared minus x minus 1, and then the square root of x plus 4. You could put y equals in front of them, or you don't have to as long as there is an x. And we're going to click on the intersections, but I made a note to be careful not to click on the x or y intercepts, because there is going to be a point that comes up that is the x and y intercepts. Desmos automatically finds those for you, and sometimes if you're very zoomed out, you can't really tell if it's a point of intersection or an intercept. So we're going to make sure that we zoom in closely to make sure that we are clicking exactly on an intersection. I'm going to click right here on this intersection where the square root function intersects with the parabola. And it says round to the nearest tenth if necessary. So I'm going to write the ordered pair, negative 1.2. The nearest tenth means it's one place after the decimal. And then 1.67 would round to 1.7. So when it says to find the solutions to a system, it's going to be an ordered pair where they intersect. See if you can find the other solution. The other solution right here, if we round correctly, would be 2.4 is the x-coordinate and 2.5 is the y-coordinate. Let's do another example. To solve this system of equations, I'm going to type in the square root. I'm going to type in the square root of x, and then you've got to be careful about what is under the square root and what is not under the square root. So I'm going to press the right arrow so that the plus 6 is not under the square root. And I'm going to type the other function, which is an inverse variation function. And again, you've got to be careful when you type these in for what is under the square root and what is under the fraction bar and that kind of thing. So let's see if we can find the solution to this system. Right here, this is, if we round to the nearest tenth, 2.8 and 7.7 would be the y value. Now, something that is very interesting is that you can use Desmos to solve an equation using the same method. So this is a system of equations. System of equations is looking at where graphs intersect, but an equation looks like this. It's just one equation, but you can use Desmos to solve an equation by putting y equals this and y equals this and clicking on where they intersect, or basically putting both sides of the equation, typing both sides in to find where they intersect. So I could put 1 over square root, remember I type SQRT, and then I want to find where that intersects with 2 over x. You've got to be careful to not click on the x or y intercept so that you can clearly tell where the intersection is. Okay, the intersection comes up right here, and that is about 6.5. But when we solve an equation, we're only looking at the x value because there's only x in this equation. There's not a y. Y would be what you get if you plug this answer in, but x would be about 6.5 approximately. So we're only looking at x when we solve a equation, a system of equations. We look at x and y. Number 4, which of the following functions, when graphed with this, has no points of intersection? We're actually going to do this one without Desmos because we know enough about our functions. So this square root of x minus 5 plus 4, I know the parent function of that. What would that look like? The parent function would be the square root of x, and that starts at 0, 0. But like we learned in the last section, those numbers are going to transform the parent function. We have h and k are going to shift this. So what would the negative 5 and positive 4 do? The negative 5 is going to move it to the right 4 units. Remember HITVO, the inside is what's tricky and moves it horizontally, and that's under the square root. And then the plus 4 is going to move it up. So this would have a starting point at positive 5, positive 4. We're going to see if we know enough about these functions without Desmos to see if we can figure out which of the following, when graphed on the same coordinate plane, would not intersect. Okay, I want you to look at these answer choices. Think about their parent function and what would not intersect. Y equals negative square root of x. That takes the parent function square root of x and flips it over the x-axis. So would these ever intersect? No, they wouldn't. Okay, that's why those would never intersect. Looking at the x minus 4 squared, that comes from a parent function of x squared. The minus 4 would shift it to the right 4, so that would probably intersect. This 3 over x minus 9, and we're trying to do this without Desmos, so we don't know exactly how it would look, but I have a pretty good idea that if I move this to the right 9 and the 3 would stretch it vertically, that is probably going to intersect. And if we look at negative x plus 13, and of course you could graph this on Desmos, but this would start up at negative 13 and have a negative slope. That would probably intersect, but I do know for sure that this one would not intersect, so that's why that is the answer. Okay, next, let's look at this in terms of some word problems. This is a long word problem. It says FFA is selling trees, and it tells us that the number they can buy depends on the price. So we have price, which is P, and the number they could buy, that is like the output. Okay, and then also they have an equation that tells about the number of trees depending on the price. So the price P is sort of like the X value, the input. Okay, we want to know for what price will the number of trees equal the number of trees that they buy equal the number of trees that the customers will buy. So all we have to do is set these two equations equal to each other. We do know how to solve that without Desmos because we looked at that in a couple sections ago. Or I can use Desmos. Now, you can't use letters other than X and Y in Desmos. And this one is 300 minus 6x. So I'm replacing P with X. Make sure we keep that in mind. I don't see anything on here, so I'm going to click with 2 fingers and zoom out. I know that the 300 is going to be a very high y-intercept. So that's why we needed to zoom out. All right, I can see an intersection here and an intersection here. There's 2 intersections. And let's look specifically at what this asks us. For what price per tree? Looking back at this, is the price per tree going to be the X value or the Y value? The price per tree is the X value, so we're going to look at the X values. The X values we got were 10 and 40. Now, in this case, the Y would be the number of trees that customers would purchase, and the number of trees they can sell is the Y value. So if the price was $40, they would sell 60 trees. If the price was $10, they would sell 240 trees, something like that. So we just looked at where those intersected. Another one, we have got different size squares here, and we're trying to look at the side length and the area. So we've got a couple things going on here. We've got perimeter, we've got area, and we've got side length. So there's actually 3 variables involved here. But I know that both of these equations are S equals. So if it is S equals, then I can say that the square root of A equals P over 4. I'm basically substituting for S. Okay, next it says, since the question is asking for the same area and perimeter, basically we just want these 2 numbers to be the same. So I'm just going to call those X because we're trying to figure out when A and P would equal each other. So basically, when would the square root of X equal X divided by 4? Okay, we can type these in. The square root of X equal to X divided by 4. And look at what the intersection, or if there's more than one, what the intersections would be. And I see 16 is the X value. That would make them equal to each other, also 0. However, is it possible to have a square that has a perimeter of 0? No, not really. So the X value equals 16. And let's figure out if that X value is what the question was asking for. So X is what we replaced P and A with. A represents area and P represents perimeter. This says, what is the side length? So the answer we give them needs to be the side length. Is 16, if we think carefully about this, is 16 the side length that gives the same area and perimeter? No, it's not. This 16 was the X value, and we could find the side length by either doing the square root of the area or taking the area and divide it by 4. So basically, the Y value is the side length in this equation. This is like Y equals X divided by 4, and Y equals square root of A. So the y value here would be 4, would be the dimension of the side length. Okay, next, giving these equations, determine the x value that will give the same result in the same output for both functions. Pretty straightforward. See if you can graph both of those and find the x value that would be the same for both functions. I typed both of these in, and the intersection I see is at 9, 2. But it wants the x value, so we're only going to give 9 as the intersection. Okay, this is another, number 8 is another equation one. To solve graphically means we're going to graph them and see where they intersect. This is using Desmos to solve an equation. A system of equations is multiple equations, but this is just one equation. That means we're going to type in this and type in this and see where they intersect. See if you can find the x value where these two intersect. When I typed both of these in, I see they intersect here at 0.5. If we're solving an equation, we really only look at the x value because there is no y here. Okay, number 9 has a system of equations, and this one wants us to find the smallest value of y. So what's going to happen is this is going to make a quadratic function. This is going to be a linear function. There's going to be 2 intersections. We're going to look at the intersections, and we're going to figure out what the smallest y value is. So first, let's see if we can find the intersections. I plugged both of these in, and there are 2 intersections. Make sure we're not clicking on the x or y intersects. And this says, what is the smallest value of y? So we're looking at the y values. What would the smallest y value be? 8 is the smallest y value, between 16 and 8. Now we're going to do a couple without a calculator. Solve the system of equations for number 10. We know how to do this. It says if you have 2 functions and we're trying to solve a system, we're going to set them equal to each other and solve. So I'm going to set f of x equal to g of x to figure out what the x value would be. So I'm going to set the square root of x plus 2 equal to the square root of 3x minus 2. In order to solve this, what should I do first? We should square both sides to get rid of the square root. And when you do that, it actually gets rid of the square root on both sides. So I have x plus 2 equals 3x minus 2. It makes sense that if we're trying to find the square root of this equals square root of this, then those 2 things would have to be equal. Next step, to get x alone, I would want to try to get rid of having x's on both sides. I could do that a couple ways. One thing I could do is subtract 3x from both sides. And that gives me negative 2x plus 2 equals negative 2. See if you can solve the rest of that little equation. I could subtract 2 from both sides, and that would be negative 2x is equal to negative 4. When you divide by negative 2 to get x alone, the x value is positive 2. When this says to solve the system of equations, that means we need an ordered pair. We need to find where these graphs intersect. So I have that the x value where they intersect is 2. I found that by setting these equal to each other. How could we find the y value, what the output would be? It should be the same for both functions since we found where they equal each other. I could find that by plugging 2 into x for either equation. See if you can find what the y value would be. I could plug the 2 in for x here, or I could plug it in for x here. If I plugged it in here, I get square root of 2 I'm plugging in, plus 2. That's the square root of 4. The square root of 4 is also 2. You would get the same thing if you plug in a 2 for x here. That would be 6 minus 2, also square root of 4. Lots of 2's in this question. So, without graphing, we were able to find where these two radical functions would intersect, and that would be at the point 2, 2. Let's see if we can find where these two would intersect, which is a quadratic and a linear function. We do this by setting our equations equal to each other. So what do I get if I set these equations equal to each other? That would be 5x squared minus 12x minus 3. I'm setting equal to negative 3x minus 1. You should notice that this is a 2 exponent. That means we have got our friends the quadratic equations, and we learned many ways for solving quadratic equations. We could use any of these methods. I like factoring, as you know, and this can be solved using factoring. In order to solve this using factoring, first of all, I need to make the equation look like this. And how can I do that? I could add 3x and add 1 to both sides. Add 3x and add 1 to both sides. Now I have 5x squared minus, this gives me 9x, and this gives me minus 2 equals 0. The first step was to get it equal to 0. Okay, next we do a GCF check. Is there something I could divide all three of these terms by? No, there's not. Next, since there's 3 terms that we're factoring, we use MACAB. And this is one where a is not equal to 1, so we're going to need to use the box to factor this, because a is not equal to 1. We're going to turn this into 4 terms. So the 4 terms I get, we're going to put the ax squared plus something x plus something x plus c. So the 5x squared goes here. We need to figure out what these two numbers would be. And then we put the c value here, which would be what? Negative 2. All right, so I need two numbers that multiply to get a times c. And a times c would be negative 10. The two numbers that I find need to add to get b, which is negative 9. What two numbers would multiply to get negative 10 and add to get negative 9? The factors of 10 are 1 and 10, or 2 and 5. So I would need 1 minus 10, plus 1x minus 10x. Almost done. Next thing I need to do is pull the factors out of the box here. Remember, this sign is going to be in the middle of my factors, and so is this sign. Okay, the greatest common factor between 5x squared and 10x, what would the greatest common factor be between those? I could pull out a 5x, okay, right here between 1x and negative 2. I can only pull out a 1. I can only pull out an x here. And what would I need in this other factor that would multiply and make this box work? I could pull out a 2, because negative 2 times 1 is 2. All right, so we did all that to break this down into factors. 5x plus 1 times x minus 2. Like I said, we could have used the quadratic formula or completing the square or anything like that. That would also work. All right, I'm not done yet. What do I still need to do after I factor? We still set each factor equal to 0 and solve. So I'm going to solve 5x plus 1 equal to 0. And I'm going to solve x minus 2 equal to 0. Let's look at solving this little mini middle school equation here. What do you get for x? I could subtract 1. That gives me 5x equals negative 1. What else do I need to do to get x alone? Divide by 5. And the x value would be negative 1/5. Over here, what do I need to do to get x alone? I could add 2 to both sides, and the x value would equal 2. Now, let's look back at what the question was asking. It said, find all values of x. That would give you an equal output for both functions. All right, usually we look at eliminating any negative options or anything like that, but I think if we plug in either of these numbers for x, it will give us an equal output. So that means both of them would be the answer if they both give you an equal output for both equations.